for the great keynote. Thanks a lot for accepting our invitation here. I think there is a lot to discuss, and the floor is open for questions. So I will start from the top left side of my screen. So let's start with Sebastian.
First of all, thanks for your talk. I'm not sure if I got it right. Do the students contribute to the textbook as well? For instance, by sending pull requests, or are they encouraged?
No.
They have to?
No, the textbook is we're just writing the textbook. So yeah.
Because apparently it wasn't the same GitHub repository. That's why I figured it might be possible to have students contribute. Maybe
no, the textbook is not in the same GitHub repository. Okay. Yeah, we have.
Okay, so that's what I got wrong.
Yeah, we should prepare the textbook. Yeah.
Thank you.
Yeah, it would be. I mean, so it would be nice to have a spin-off. I mean, there's so many logic puzzles you could code up. I'd love to have a repository. I'd love to like have now a bigger collection of these. So I think it would be a nice idea to then have a companion repository set up where anybody can contribute more examples. Yeah.
Usually with student contributions to textbooks, the tricky part is quality assurance. That's why I was wondering what you do in that respect.
Yeah, yeah. So the textbook is all us. Yeah.
Thank you. We move to the second question, Tobias.
Hi, Jeremy.
Hey,
thank
Tobias.
you for this very nice overview of your course. As you said, you've used Lean 4 primarily for programming so far. How far do you want to push this in the direction of actually getting the students to do proofs? Because it'll require a deeper introduction into Lean, and therefore you can cover less material. So what is your expectation there?
Yeah, so what we've done in the class so far is there was sort of one lecture or so on using Lean as to do propositional logic. And then there was, it spread out across 2 homework assignments, but we had them do a lot of, propositional logic identities in Lean. And, they did that and they seemed to enjoy it. And in one of the remaining lectures, I'll try to do a little bit of first order logic. So show them equational reasoning and show them first order reasoning, maybe just to show them, how to do proof by induction on lists and so on. Yeah, the semester is just about over, so we don't have time to do that on a homework assignment. I guess in a future iteration, if we move things around, we might make space to have maybe one homework assignment with equational reasoning and quantifiers or something like that. In this class, I don't see it's really, this is an introduction to a lot of things. So it's really not, the focus really isn't on having it as a proof assistant. So really just to kind of show, just kind of give them a sense. But even so, once you show them that, then you can talk about the fact that, look, what's the advantage of having one system that's both a programming language and a proof language that, for you to express things. And you can talk about the fact that, well, now you can prove things about your programs. You can verify correctness. So in this course, it's really just to introduce them to the idea and get them familiar with the concept, and hopefully encourage them to take an interactive theorem proving class later on. But yeah, so otherwise it's a very kind of minimal glimpse at what you can do with a proofer.
Thank you.
We can move to the next question, Matthias.
So thanks for the talk. It was very interesting. I was really looking forward to hearing about Lean. I'm doing a course which is somehow related, so there are some of the puzzles look similar for some of them, but I'm using Haskell. And I've always looked to Lean, in particular Lean 4, because Lean 3 is somehow, it's not obsolete, but it will not be developed any further. How stable do you think is Lean 4 now for using it?
So again, before we taught the course, we really agonized that it really is early. I think the biggest thing we worried about is the fact that there really is almost very little documentation. So students, like if you teach a course on Haskell or Java, if students want to know how to do something, you go to Google and you find answers right away. So the software was I mean, it was stable, not problematic. So that, you know, the language is holding its own. I mean, it helps. I mean, Wojtek is involved with the lean development team, and so you know, we have an inside track. So it's still is early, but even at this stage, it was pretty stable. It held up just fine. You know, I don't know, maybe, and it's getting better. I think 6 months from now, it'll be a lot more stable and so on. So it's still early, it's still pre-release, documentation isn't there, but it worked well for us. I would recommend, yeah. I mean, there are caveats. There's reason to have a little bit of concern, but like I said, it worked great for us, and so yeah, I would recommend giving it a try.
Okay, thanks.
Good. If there is no other question from the audience, I can ask one. We have seen during the workshop that there were different approaches for teaching, like some of the courses were more targeting the teaching from a theoretical perspective, some more from a practical perspective. You kind of reach a compromise between those, right? Is there anything you would like to change or something based? I know that probably you just joined the workshop due to the time zone,
Yeah.
but would you can you comment on what you want to change in the future, if there is something you would like to improve with respect to how you merge all this theory, practice, and
Yeah, I am so happy with the way the course has turned out. I think it's, yeah, I mean, little things that we can tinker with, and you know, fix typos and better explanations in the textbook and so on. But my favorite thing about the class was really this kind of the three strands and jumping back. And I mean, one advantage is, you know, when students get bored with one thing, you switch to something else. So there really isn't any time to get bored with, you know, if we spent all the time just coding up, you know, Sudoku puzzles and so on, I think it would get boring. But, you know, so the variation, I think, helps, you know, keep up interest. But really just being able to go back and forth, again, to show the definition of a propositional formula, you know, the mathematical definition, and then code it up and then use it. I found that very satisfying. So for me, I think that kind of that kind of interaction is really the most wonderful and interesting part of the course. So yeah, I do recommend trying to do something like that.
Joao?
Hi, thank you, Claudia. And thank you, Jeremy. Very nice talk. So I'd like to follow up on Tobias' question. So I know that the emphasis here is not really on using Lean to prove things, at least interactively. But I mean, do you have any experience teaching interactive proving using Lean? And does Lean 4 supports a structured proof format, or do students have to write proof scripts? I mean, do you have a recommended way on how to do it from your experience?
Yeah, so if you actually, at any point, if you send me email, I can give you more information. But the quick answer is I have taught courses. So one reason that we wanted this at the 200 level is, you know, this is like a second year course that now students have room to go on to other things. They can take Marian's, you know, SAT solving course. They can do bug catching, you know, model checking, formal methods. I have taught interactive theorem proving classes based on Lean 3. Next semester, I'll probably be doing one, sorry, not next semester, in next fall, a year from now, I'll probably be doing one in the mathematics department at Carnegie Mellon, targeted to mathematicians. Yeah, I have used Lean 3, and I have a course called, I've taught a course called Interactive Theorem Proving, where I relied mostly on theorem proving in Lean and some other things. So I'd be glad to send you, you know, more information. But yeah, you can. It makes for a great course. So I mean, a dedicated course on interactive theorem proving is definitely a good thing. And concretely, right now, the recommendation is if you want to do anything with, so Lean 3 has a substantial mathematical library, you know, like 700,000 lines. Lean 4, the library will be ported, and yeah, Lean 4 that will have all the tactic proofs, structured proofs. So it'll, I mean, it's not backward compatible. The language is somewhat different, but I'll have, you know, it'll be similar. But yeah, the advice is if you want to do a course on interactive theorem proving now, I would do it with Lean 3. But yeah, the port, it's yeah, within we'll see. But within 6 months, we'll see. You know, porting 600,000 lines in formal library, but it is critical path. A lot of people are working on it now. So when the port happens, go to Lean 4. Before that, use Lean 3.
Okay, thank you.